Good afternoon, everybody. Welcome to TXAPA Live. My name is Jim Warren. I will be your host this afternoon, and we are ready to get started. So come on, sit down, grab a cup of coffee, and let's go ahead and get started. Today is Sustainability Month, or this month is, and we are spending a lot of time talking about different programs and issues that are going on. And today we continue our program, and we've got Joseph Shacat, who's the Director of Sustainable Pavements with the National Asphalt Pavement Association, here with us to talk about a little bit about what is happening nationally. Joseph, welcome to TXAPA Live.
Good afternoon. Thanks for having me.
How are you doing today?
I'm pretty good. It's a little chilly here in Maryland, but otherwise happy to be here.
Good deal. Yeah, we've got a little storm brewing through. Supposed to start it out on the West Coast. It's supposed to come through tonight and bring us a little needed rain tomorrow, and then it'll probably heat back up, and we'll go ahead and get started. So we are going to talk about sustainability. So let's let me see if I can get our slide deck moving and get us switched over there. I'm going to bring you in up there, and I'll bring me in up here so we can talk a little bit. I'll come in and out as needed. So we're here to talk about sustainability. So, but before we do, I'd like you, for a lot of people don't really know who NAPA is and what NAPA is about and what NAPA does. So give us a little overview of what NAPA is doing and what they are about. So go ahead.
So NAPA is a National Asphalt Pavement Association. So we're the only trade association that lobbies exclusively on behalf of or represents the asphalt pavement industry at the national level. And so, we have about 1,200 member companies, most of which are mixed producers and paving contractors, but we also represent the equipment producers, equipment manufacturers, and material suppliers. Some of the things that we do, we have a pretty strong research and engineering team, and we are affiliated with or have really good bonds with the National Center for Asphalt Technology at Auburn University in Alabama. So they're not really part of us explicitly, but we have a really good relationship with them and send a lot of research work their way. And then, but we also sponsor our own research projects and help kind of set the national research tone through cooperation with the Transportation Research Board. As far as education and member services, we have webinars and conferences and that sort of thing. The types of things that trade associations typically provide for their respective industries.
Good deal.
And then we have we also have a last thing here is an advocacy arm, and that deals with the lobbying things on Capitol Hill, and then advocacy for things like regulations, environmental health and safety.
Good deal. Yeah, lots of stuff, a lot of things to do in the association world, and sometimes you run into people and go, "What do you do?" "I work for an association." They go, well, "What does that mean?" And you got to take a half an hour to explain what all you do. So appreciate it. Yeah, I did my tour up there a long time ago, and it was a good time. NAPA does some good stuff. So welcome aboard. Welcome to Texas, and glad to have you. And let's plug away here. I guess the question is, it's Sustainability Month. It's green. Today's Green Day, I guess it is, or yesterday was. And, I think the word sustainability means different things to different people. So I'd like to have you kind of define what you mean by when we talk about sustainability, since it's in your title. So go ahead.
Well, I think the easiest thing is to start with the Federal Highways definition. They define this in a reference document they compiled a few years ago. And they say that sustainable pavements should, one, achieve the engineering goals for which they're constructed, right? Okay. So if you're thinking about it from that perspective, you got to make it well, right?
Sure, absolutely.
4 is quality is job 1, right?
Yes. Asphalt.
Preserve. 2 is preserve and ideally restore surrounding ecosystems. So how can a pavement restore an ecosystem? You ever wonder about that?
We've talked about that here. We've actually had some webinars on that. Absolutely.
Interesting. So I like to think of this as your porous pavement as being restorative, because you restore that natural hydrological function of rainwater recharging the groundwater underneath and not just running off into the storm drain system. Yeah.
Yep.
And then the third one here is using financial, human, and environmental resources economically.
Okay.
What does this mean? It means don't waste, right? Don't waste time, don't waste money. Don't waste the environment. Don't waste our natural resources that we have, right?
That makes sense.
And
yeah.
Yeah, and then the last one is meeting human needs such as health, safety, equity, employment, comfort, and happiness. And I really like the happiness one.
Sure.
Do pavements make you happy?
They do when I'm driving on them.
I sure hope so. My story about this that I would say is when I was in high school growing up in South Pennsylvania,
Okay.
Route 1, you probably know about Route 1 even if you don't live on the East Coast.
Sure.
Old concrete highway, you're driving down the road, all the joints. And I used to hate driving on Route 1. And I was about 17 years old, and they resurfaced Route 1 in that area of Pennsylvania. And I remember thinking, man, this is going to be out of construction for months. This is going to be terrible. Well, the next week, it was all open because they resurfaced it with asphalt. And I was shocked that it was that quick. I'm 17 years old. Yeah. And then I was like, this is a great highway. It's so smooth. It's wonderful, right? So that's, that made me happy.
Yeah, well, my wife and I, we'll drive on the weekends and just go out and see stuff, and can always tell when she gets a little irritated. I can tell what kind of pavement surface we're on, and when she starts to relax a little bit. So yeah, it's all good stuff. It's all good stuff. So okay, that makes sense to me. There's a lot of stuff going on there, even further than a lot of people think about when we talk about sustainability. But there's other terms out there now as well, like EPD, LCA. So let's help me understand, or help us understand a little bit more about what those terms mean as we move forward through this program.
Yeah, good question. So I think about, when you think about sustainability, one of the things that people want to do is quantify it. What are the total impacts in a number that's a real number that you can attribute to a material or pavement. And that's, you do that through what's called a life cycle assessment.
Okay.
And the LCA should go from cradle to grave, or in our industry, because we recycle so much, I call it cradle to cradle, right? Because you're just going
because it's continual. It's an evolution.
Right.
We don't throw roads away, right?
Right.
Yeah.
And so what you do is for each of those life cycle stages that you can see on this diagram, you're quantifying all the environmental impacts associated with each of those stages.
Okay.
Now, an EPD, all it is it's an LCA that meets certain requirements, which are described in something called a set of product category rules for individual types of products.
Okay.
And it meets all the requirements for conducting that LCA, and then it discloses them in a report called an EPD. That's the declaration, Environmental Product Declaration. And then an EPD, in most cases, is only looking at those first initial life cycle stages. Materials, what are the impacts of extracting and processing the raw materials? So this is the aggregate production and binder production, for our case, transporting those materials to your plant, and then your plant operations.
So the EPD stuff is a environmental product declaration that it's not just an asphalt thing. It's everything, right?
Yeah, I've seen EPDs for pasta noodles. I've seen EPDs for literally.
Really? Okay.
And it's like one of the companies like a 45-page EPD on pasta noodles, and it's fascinating. It's how to cook the pasta noodles and how they're grown, and it's really interesting stuff.
Do they say they cook it al dente, or does that reduce the time? I like mine cooked a little bit beyond that, but anyway, that's very interesting. I'd never thought about that. So we're looking at the total life cycle of these pavement systems, but we're focusing more kind of on the production side, I guess, because we can get a better handle on that, and they're more definable. I mean, traffic and use, it's really kind of a wild card as far as trying to get a hold of that. But how detailed does this process get?
Yeah, good question. So we do focus on those initial life cycle stages because that's what we have control over. The other ones, you're going to start looking at the agency to do that full life cycle assessment for their road, right? It's more of a road thing. Okay. But getting into the EPD itself, this is an example of one of the data tables that's going to be in the EPD for an asphalt mix. The whole thing's about 5 pages long, and there's a few data tables. There's a lot of description. But this is the one that most people tend to be interested in. And what you see here is a number of environmental impact categories on the left. And so the first one is the global warming potential, and that's in kilograms of CO2 equivalent. So it takes all the nitrous oxide, methane, and CO2 emissions and other greenhouse gas emissions and puts them into a single unit that's makes it easy to compare.
Okay.
And then there's other impact categories like ozone depletion. Remember the hole in the ozone layer back in the 90s? We were all concerned about that.
Yep.
Acidification for acid rain. Eutrophication, that's the dead zone, right, off of the Mississippi Delta, for example, and the Gulf.
Oh, okay.
So that's that eutrophication potential. So these are some of the things, and the smog is going to be obviously the direct smog producing emissions.
Well,
and then this is
go ahead.
This is quantified then for each of those first three stages. A1 is materials, A2 is transport, and A3 is mixed production.
So then the sum of those is the impact for each one of those different areas then?
Correct.
Gotcha. Well, there's some new words and a lot of syllables. I think I may need an aspirin after this one. But so what are we going to use? What's the purpose? What do we use the label for?
So this initially started because the U.S. Green Building Council back in, I want to say 2012 or so, was putting together a revision for their LEED program. And they said, oh, in this next version of LEED, we're gonna use EPDs as part of our credit criteria for earning credits. It took them a long time to revise the actual LEED program to do that. But now most of the green rating systems, LEED and others, are all using EPDs. But also agencies are looking at it potentially for decision making. And the first one that's doing this is California right now. They've actually passed an act. Their act does not apply directly to asphalt, but Caltrans is collecting EPDs for transportation projects, including asphalt and aggregates.
Okay.
And that's on a pilot basis.
Okay.
So it's not a kind of regulatory requirement, but they're just doing it because they say we want to manage this at the agency level and not be kind of constrained by state law. And then the lightly shaded yellow on this map, these are all places where there have been either state or local proposals for similar legislation. So Austin, City of Austin had a proposal a couple of years ago. That's why they're on here.
Okay.
More importantly, there's currently a draft bill that's been introduced to the House on a federal buy clean policy. And there's also in the works, the GSA, from what I've been told, is planning to put together a proposal to incorporate EPDs into direct federal procurement. So this would be anything you're doing with national parks, DOD facilities, presumably, right? So it's coming. It's on the horizon.
Okay, so it'll start at the federal level because they can require it on those kinds of projects, but then there are a number of states listed here. Actually, I thought other states were ahead of us, but it's actually good to know that Texas isn't at the end. But there are a lot of states out there. It looks like they haven't done anything yet. So I guess they're just kind of waiting and seeing, and let's see what happens. Obviously, some big changes, huge impacts to the way things would be done. And things would be bought. So obviously, it's a good thing we got you up in Maryland to look after this stuff for us and keep us in the loop as what's going on here. So, all right. So let's, given all that, let's talk a little bit more about asphalt and maybe what some of the sustainable features is involved therein. So let's talk some more about that.
So I think one of the things that I love about this industry is our history of recycling. If you're in this industry, we use a lot of RAP. I think nationwide in 2019, it was almost 90 million tons of RAP was used. That's a lot of material.
It's a lot of material. Is it true? And I've read this a couple places. Is it true that asphalt is recycled more than all the other major recycled materials together? I've heard that a couple of different times. It's like recycling paper and plastic and steel and if that's true, that's crazy. I mean, that's a big number.
So there's a few different ways to cut it, and in some measures, yes. In some measures, yes, that would be the case. And an example, to me, the measure of where we're the leader is the percentage of material generated that's recycled. Okay. So that's where we're clearly a leader.
Okay.
So that's great. You look at concrete, there's more concrete recycled technically per year, but most of that's going into low value kind of aggregate materials. The difference with asphalt is that it's actually, you're reusing that cementitious property of the binder, right? And that's
at the highest level you can.
Exactly.
Right.
Exactly. That
Okay.
Highest and best use.
Highest. That's it. That's it. Highest and best use. I was trying to remember what that was, and so we're actually getting the full value back out of that material, where some other materials are they're used for waste, or they're burned, or I mean they're something's done with it. They're not just thrown away, but they're really not using it back into the actual product in the way that it was originally designed to be used. And I think that's a pretty cool thing about our product.
Right.
So
now, one of the things that we do every year is we've been for now 10 years, we've been collecting industry data on how much recycling we do, whether it's RAP or RAS or other materials, and also our war mix usage. And this, my kind of call to action for folks from Texas watching this is we're collecting our data. You see Texas on this map is red. It's a little bit out of date. That's from a couple weeks ago. At that time, we hadn't received any responses.
Oh, that's not
Texas
good.
Contract.
All right, boys, step up, cowboy up.
Yeah. So I'll drop a link into the chat box here for where you can go to submit your data. But we really need you to participate.
Okay.
Texas has like almost 10% of their lane miles of roads in the country.
Yeah, there's a lot.
So
there's a lot here. All right, well, okay, you kick me in the pants. We'll get going on it. We'll get going on it. We hear you.
So as far as the benefits for asphalt and using RAP in particular, this is kind of thinking about that circular economy, using our own materials back into our products. Millions of tons of liquid asphalt binder that we're not, you don't have to extract out of the ground anymore and make into your product. 84 million tons of aggregate. So by reducing the need for these raw materials, you're reducing greenhouse gas emissions. And what we calculated in 2019 was almost 2.5 million metric tons of greenhouse gas emission reduction. And that's the equivalent of over 500,000 cars, right? So that's a pretty big impact.
Yeah, that's about how many are on I-35 at rush hour around Austin. So
I've been in Austin at rush hour, and I would say it rivals Honolulu. So that's pretty bad. But I will say it's not just that we're reducing greenhouse gas emissions, but we're doing it and we're saving money at it. That's if you look at the value of those raw materials that we're replacing, it's over $3 billion in value as a country.
So that's tax dollars that we can use to build more roads and rehabilitate other things and keep things at a higher level of serviceability that we're not wasting on other things. So yeah, that's good stuff. So yeah, there's great value to recycling. As you're showing here, both from an environmental, from an economic, and also from an engineering side. So right on. That'll work. So obviously, big numbers here. So what else does asphalt offer as far as on the sustainability side?
Well, this is, I think, when you think about greenhouse gas emissions in particular, what's important to remember is that, the pavement is, you would say, part of the transportation industry in that sense, that we're providing the groundwork, the infrastructure.
Right.
And so this graph there's kind of a lot going on here, so I'll break it down real quick. Okay. This was done back in 2003 by Colas, right? It's an asphalt mix producer, and this is their European, I guess, parent company that did this analysis. And the black line is what this is showing you, the black line on the top. That is vehicle emissions on different types of roads. So all those different columns, they're different types of roads, ranging from, say, like a local road to an interstate highway.
Okay.
And so what this is showing you is that the emissions associated with the vehicles driving on that highway are much higher than the emissions associated with building and maintaining the infrastructure, the pavements and other infrastructure.
Oh, okay.
And so, and then the red lines and the blue lines down here, this is showing different pavement types.
Okay.
and all the emissions associated with, building and maintaining those pavements.
I got you.
And so this is like one of the initial things that showed that, asphalt pavements have a lower life cycle carbon footprint than concrete pavements, but also that the emission difference between the pavements and the vehicles is huge. It's like a factor of 100 or more in most cases.
Yeah, you're right. I mean, that is a huge number. It's not a linear scale there. So, that is good to keep in mind. That is good to keep in mind when we're having these discussions.
And so the thing about smoothness here is we know that smoother pavements are more fuel efficient because there's less, rolling resistance in the vehicle.
Right.
So if you think about if you could reduce the rolling resistance, improve the smoothness of most of our highways across the country, and yield, say, a 1% improvement in fuel consumption.
Okay.
1%.
Oh, you locked up there for me. Come on back. Are you there? There you go. You locked up. Go ahead. You were talking about a 1% change. Go ahead.
Yes. So if you could reduce that vehicle fuel consumption by just 1%, that would be enough to offset all of the U.S. asphalt mix production, cradle to gate.
Whoa, no kidding.
And so it's a really big benefit to be able to maintain your roads, keep them smoother, and actually have a net reduction in greenhouse gas emissions.
Wow, and that's all achievable, right? I mean, we have the ability to make extraordinarily smooth roads. I mean, we're in the middle of looking at our awards program right now, and I've got to go next week and go look at a project, and it's got IRI values down in the 20s, which is crazy. It's crazy smooth, and I am really looking forward to riding on that roadway next week. So I've got a lot of roads in between to ride on as well. So smoothness does matter. I think in just the vehicle itself, and also wear and tear in the vehicle as the roads get rougher and rougher. We know what happens, springtime after the thaw in the north. There's a lot of work to be done on the roads, and fortunately down here it's not too bad. But we did have a pretty darn good cold snap here a couple months ago, and it was pretty amazing. I hadn't seen weather like that since a long time. So, all right, so we're comparing smoothness, we're comparing vehicle emissions to pavement types and the ability to make pavements. And we know asphalt has got a smooth ride, and we can make it an extraordinarily smooth ride. But let's get back to the sustainability discussion. How do all of these things, how do they tie together?
So this is some work that was done by the UC Davis Pavement Research Center in California, for Caltrans, the California Department of Transportation. And they looked at about a half a dozen different potential strategies that the department was considering for reducing greenhouse gas emissions. And you can see some of these are, the first one, strategy one, the blue, is increasing the allowable RAP in asphalt mixes to 50% using a soil oil-based rejuvenator.
Okay.
And then they did some other ones, like, some of these are a little exotic, piezoelectric energy harvesting underneath pavements, using the state right-of-way for renewable energy, right? And then one of them, the green one there, is optimizing their pavement maintenance schedule to improve smoothness and reduce fuel.
Oh, okay, sure. Okay.
So this type of graph is referred to as a supply curve, and it's a way to kind of look at both the economic and the environmental, or in this case, greenhouse gas emissions associated with different scenarios.
Okay.
And the vertical axis on the left tells you the cost effectiveness of a project, of a given program. And the negative numbers for the blue for this scenario for high RAP mix design tells you that the agency is going to save money while they're doing this. Right?
So the more negative it is, the more positive it is actually.
Right.
Okay.
Exactly.
All right. Gotcha.
So in this case, using RAP was the most cost effective of the six different technologies they looked at. And then the horizontal bar, or the horizontal x-axis, is telling you the total amount of greenhouse gas emissions that can be reduced. So, if you're going pretty far, if you're really wide, then that's a big reduction. And if you're narrow, then that's a small reduction.
Okay.
And the most effective thing here is that option of optimizing pavement smoothness by increasing, you're optimizing your maintenance schedule.
Okay.
Now, this had a slightly positive economic value here, and it wasn't very big, but it was positive. But this is only looking at the agency's cost.
Okay.
It's not looking at the benefit from users of reduced vehicle fuel consumption, reduced wear and tear, and all that sort of thing.
I got you. So if that was in there, that would also be a very large negative. So I see your point there. Is that wide horizontal line is very significant. They may not see the cost, but there's a very significant a benefit to have that. But there is a significant cost savings to the agency on using higher RAP percentages as well. So okay, very good. That's very interesting. I've never seen a curve like that. So that's learn. I try to learn something new every day, and I got it now. So okay, so we get the benefit of the RAP, the engineering properties. It's got good residual properties. There's a cost savings there as well. But they can also be used to actually make pavements last longer. So let's talk a little bit about long life pavements and perpetual concepts. So let's see what you got.
So perpetual pavements, if you're not familiar with this term, this is designing a pavement so that it's never going to have a structural failure. You're never going to get that structural rutting or bottom-up structural cracking. And to do this, you're typically making it a little bit thicker than a traditional pavement that you might, instead of designing it for 20 years, you're designing for a much longer useful life. And you might have specific layers that you wouldn't necessarily have in a conventional pavement design. Like your bottom layer might be you have a rich asphalt bottom layer to prevent that bottom-up fatigue cracking. So it's going to kind of help self-heal or not have enough strain that it's going to crack from the bottom up. So that's a basic concept. So by doing this, you now have a thicker, stronger pavement structure, and it's going to last a lot longer. And all you ever have to do is go in and resurface that upper, a couple inches of surface wearing course.
Gotcha.
So this is a case study that was done by Federal Highways Administration. Just last year, they published it for a highway in Iowa, where they were comparing a perpetual pavement design to a conventional alternative. And they found that the initial financial cost, was a little bit higher on the front end, but the life cycle maintenance reduction ended up saving about 20% of the life cycle cost. Wow. And they also found that most of the environmental impacts they analyzed, including the greenhouse gas reduction, was about 20% as well. So here you are, you're saving money, your life cycle cost reduction, and reducing greenhouse gas emissions and other environmental impacts.
Sounds like something we need to keep an eye on, or we need to be looking at. I know TxDOT has a perpetual pavement concept in their design guide, so I think we need to look a little bit more than that. So we've got about 5 minutes left or so. So let's kind of shift gears a little bit. I keep hearing this word resilience. And so I want to take a little bit of time about that and delve into that just a little bit. So let's talk about resilience a little bit.
Yeah, the hot topic for sure.
Yeah.
So FHWA defines resilience as the ability to anticipate, prepare for, and adapt to changing conditions and withstand, respond to, and recover rapidly from disruptions.
Okay.
So it's not just about hardening your pavement if you're talking about infrastructure.
Okay.
It's about being able to rapidly recover when you do have damages to your system. And so it's you got to keep that in mind. It's a combination of both of those.
Okay. So what does hardening mean?
So hardening will be strengthening the structure. So a perpetual pavement is actually recognized as a resilient attribute for pavements.
Okay.
Yeah.
All right. So let's keep talking about it. How does all this work together in the pavement world?
Yeah. So that last click you just did just showed how you kind of quantify resilience. Some agencies are starting to think about this, where you kind of just integrate that area above the curve.
Okay.
So let's go on to that next slide because I think it's got some good information here. So when you think about responding to an event, the first thing is you want to be able to get back and repair your road quickly. And there's lots of great case studies of using asphalt to restore service and get everyone running again quickly. So that speed of construction is super important.
Sure.
From that side.
Yeah.
And agencies can't afford to harden all the roads, right? You kind of have to say, you know what, we're just gonna have to let some of these roads fail, maybe most of them, and then fix them when they're broken, right? So this is a really key asset for our industry.
Gotcha.
And then there's different things you can do to kind of use warm mix asphalt in cold weather or long distances.
We talked about warm mix last week. Yep.
Yeah, and that was a great presentation. And so this is another resilient kind of tool that you can have for repairing pavements. Recycled materials, which we talked all about today, can help you reduce your supply chain requirements. Sometimes maybe you don't have access to aggregates or binder from your normal supplier during a hurricane or after a hurricane. So using RAP can be really helpful for reducing those supply chain requirements.
Yeah, having lived in Florida for a couple almost 2.5 decades, and seeing what some of the storms can do, they can reach pretty far inland and wipe out a road. And a lot of those, roads along the coast, that is the road. There's no road inland. And watching, the contractors work with the agency to rebuild a road, and sometimes a matter of hours. Not weeks, to get these things back into service, and the product they're using is asphalt, and it was always very kind of made you proud that your product was able to get people back moving again. So I'm getting the theme that asphalt's got a lot to offer in these areas. So let's keep talking about maybe a little bit more.
Yeah, so one of the key things, if you want to harden a pavement, we talked about perpetual pavements. It's a great way to harden your pavement, strengthen it. It's a really good option if you're in a coastal environment. I know Texas has a lot of coastline where sea level rise is a concern. And if you're thinking about that, and with sea level rise, you might get groundwater intrusion coming in and saturating your base or subgrade material, can weaken the pavement structure. So perpetual pavement is a really good option to consider when you have that concern. Or deep reconstruction, where you're just stabilizing the base and that sort of thing.
Yeah, I mean, we've just looked at some work that we've had one of the universities do for us, and they're talking about the attributes of actually stabilizing the subgrade and what the actual benefit of that is, as opposed to using an unbound. So that, as far as pavement life, in addition to hardening, gives us another tool in the toolbox to kind of look at some of this stuff and keep moving forward. So what are the steps of working this out as far as resilience goes?
So there's some other tools that we have available too. And so some of them are looking at your design of your pavement to begin with. So if you're doing, say, using PaveME for your design software, or using LTTP bind to select your binder type, those use climate data in the software suites.
Right.
But they're using historical climate data.
Okay.
There's some new techniques coming out. They haven't been really widely implemented, but there's definitely states that are looking at it and kind of starting to incorporate this, using future climate models to inform your pavement design.
Okay. Looking back and forward.
Right, okay. Right. So I know Federal Highways did a case study in Texas a few years ago on this, and they found that the biggest issue was maybe in about the year 2040 for a highway that was being designed, you'd have to bump your binder grade from a PG70 to a PG76.
Okay.
So it's a relatively modest change, but they kind of were able to say this is when we think it's going to happen, and they can kind of incorporate that into their cost planning, that sort of thing.
Well, the performance graded binders really are a benefit, and we've already seen a lot of surfacings go to a 76-22, and we're even talking about going higher in some areas. So I think in that case we might even be a little bit ahead of the curve.
Yeah, and the fact that you could call it a climate adaptable material, right? Because as the climate changes, when you maintain that road, it's really only the upper couple inches of that surface that's going to get really hot anyway from hotter temperatures.
Right.
So it's an opportunity every 10, 15, 20 years, whatever your maintenance cycle might be, to go in and make that change.
So you can upgrade.
Right.
You can upgrade. Awesome. Awesome.
Yeah. Yeah. And then the other thing is this porous asphalt. I think this is a really big deal because you can use porous asphalt to reduce your, a watershed's impervious surface area. That's a great way to restore that natural hydrological cycle and reduce the flooding risk. Good deal.
Good deal. All right. Well, it looks like asphalt's pretty well suited to do a whole bunch of different things, and it's always, it's always great to be in an industry that has never shied away to step up and take on a task of trying to improve their product. And looks like it's we still got some work to do. It's it's a great place to work in this industry, and we love it. So. Closing comments, Joseph. Again, we enjoyed our time together here. Time has just shot away real quick as it normally does. Closing comments, call to action. Where should we go from here?
First thing is a reminder, please complete the survey for our Warmix and asphalt recycling.
There we go.
Number one thing. The second thing, don't be afraid of sustainability. There's a lot of opportunity out here to reduce your cost, increase your market share, attract and retain employees. More and more younger folks are interested in this for the companies they work for. What are they doing to reduce environmental impacts and that sort of thing? Don't be afraid of it. And then the next thing I would say, start thinking about, how do I quantify where I am? And, we have that EPD tool. It's really cost effective and it's not that hard to use. That's a good starting point. But even before that, we have a free greenhouse gas calculator on the NAPA website in the sustainability section. Check that out and just start thinking about baselining yourself and your own operations and then seeing how you can improve those operations with different mix designs, using more RAP, using Warmix, other energy efficiency measures. This will really kind of help you lay out your own company's path for how to reduce greenhouse gas emissions, for example.
That's awesome. That's awesome. Joseph, thank you so much for your time today. Great information. Thank you all for joining us today on TXAPA Live. Next week is also National Work Zone Safety Awareness Week. Reminder that safety is everybody's business. Next Thursday, please join Chuck Fuller and myself for a deeper dive back into our fundamental series as we get back into asphalt paving operations. So until then, be safe. We'll see you next time on TXAPA Live.